All right. Welcome, everybody. Good afternoon. Kinesiology week 7. So last week we were looking primarily muscles of the elbow movers. Now we are moving down into the wrist. So now we are looking generally at wrist muscles, wrists and fingers. Before we really get started, I do want to mention one thing to you guys. Looking through the quizzes that you guys are turning into me, generally you guys are doing great. You guys are doing great. But I do want to point out, I want you guys to pay attention to the answers that you're submitting. Sometimes autocorrect is getting you. So for certain things, I can see what the mistake was, and I see where you're coming from. For example, somebody turned in an answer. The answer was external obliques, and autocorrect got you, and it said eternal obliques. I'm all for eternal obliques, but I could see that mistake. I could tell that was autocorrect. I give you full credit. But for the insertion of quadratus lumborum, QL inserts on the transverse processes of L1 through L4. So if you mistype a 4 and instead put 5, that's wrong, right? Because that's not the bony landmark. So please give your answers a quick proofread before you submit, because if I can understand what mistake you made, I can try to work with that. But if it's just a wrong answer, even if it was autocorrect, if it's just wrong, I can only grade what you give me. So quizzes, that's what I wanted to say. Good stuff. Good stuff. Okay. All right, friends. Week 7, we are looking at muscles of the wrist and hand. So I feel like we've pretty much covered the bony landmarks of the elbow. Moving down, the main issue, less so than understanding the bony landmarks, is making sure that we understand the bone structure and how these joints are going to allow movement. Now, you guys have been moving your hands for probably a really long time, but I do want us to take a quick review through the joints of the hand, just so we understand how it can move in principle. We're going to start with the bones of the wrist. Now, most of us kind of instinctively come down here when we think of the wrist. This is ulna and radius. This part is not moving. The wrist bones are here. They're properly in the hand. So if you were to cut the hand off at the wrist, all of those little wrist bones would actually be in the hand. So we're looking right here. We have 2 rows of 4 bones. So 4 proximal, 4 distal. And we have, of course, the names scaphoid, lunate, triquetrum, pisiform. Those are starting from, remember, in anatomical position, the thumb is lateral. So when I rotate my hand, we have to kind of warp our brain a little bit. This is lateral, this is medial. So from lateral to medial, scaphoid, lunate, triquetrum, pisiform. Pisiform is the one that you can feel right there on the corner of your wrist. It feels like a little P. That's the pisiform. So we reset, go distal just a little bit. Now we have the hamate, capitate, trapezoid, and the trapezium. Wait, that's not right. That's not right. That's from the medial side. I reset like this. The slide is doing it differently. The slide is going like this. Sorry, I messed you all up. Sorry. Scared lovers try positions that they can't handle. The hamate is there. Hamate and the pisiform go together. So we have several mnemonics we can choose from. We've got Sally left town pregnant, Harry caught the train. It's a funny one. I prefer scared lovers try positions that they can't handle. That's just the one that's stuck in my brain. So all of the carpal joints are going to be gliding joints. They slide in two planes, which gives you these kinds of nice gliding movements. Next, we move to the row of these are the metacarpals. These are the bones of the hand. Then we have proximal phalanges, intermediate phalanges, only on these four fingers. And then the tips are your distal phalanges. The thumb only gets two. It gets a proximal and a distal. Proximal and distal. The rest of your fingers have three, so that they get the middle, the intermediate. All of these joints are hinge joints. They open and they close. All of these joints, they open and they close. They don't do anything else. They don't rotate, for example. So if you are looking at the palm of your hand, you can't rotate a single finger around to look at your fingernail. The whole hand has to rotate. Individual fingers are hinge joints. Now, the first knuckles, these guys are condyloid joints. These guys are similar to ball and socket joints, so they get a wider range of motion. So if you think about one individual finger, we're just looking at the index finger, we can flex, extend, we can add and abduct, and we can circumduct. We can do that with just about all of these fingers. You start to lose control as you move out, but we have the most control over the thumb and the index finger. So those are going to be condyloid or ellipsoid joints. Intermediate and proximal, those are hinges. That's all they do, open and close. The distal radial ulnar joint, so not in the wrist proper, but the distal end of the joint. Remember that the radius will rotate in place, so that's going to create a pivot joint, which will allow supination and pronation. The ulna pretty much stays stationary. It's the radius that is rotating in place. So the radius gets to rotate against a fixed ulna. Condyloid joint at the wrist, so the wrist can do the same thing. Flex, extend, ABAD, circumduct. That's a nice condyloid or ellipsoid joint. The base of the thumb is the only instance of a saddle joint. You get one pair of saddle joints in the whole body. That is it. No other joint is quite shaped like this one. When we talk about the base of the thumb, a lot of us kind of instinctively go here. This is not the base of the thumb. The base of the thumb is there, down by the wrist. Feel for that first metacarpal and then follow the bone down to the joint. You will almost feel where the metacarpal and the carpal come together. That joint surface is kind of S-shaped. It doesn't feel like a nice straight line. There's a little bit of a curve to it. If you really press in, move the thumb around so you know that you're moving the right bone. And then your finger will kind of fall into the little groove between those two bones. Saddle joints are so named because the surface is shaped like a saddle. But for those of us who are maybe not the most savvy horse riders to know what a saddle is, it's shaped like a Pringle. It's shaped like a Pringle. It's curved from one side to the other, and it's curved from front to back. So we've got a double kind of curve going on. I'll isolate this bone. Look at that proximal joint surface and you'll see what I mean. It's very distinctly Pringle shaped, right? It's curved from one side to the other, and it is also curved from the front to the back. It will fit perfectly with the trapezium. The trapezium. And there's no real nice, clean way to remember that one. It's really dumb and it's really corny, but this is what sticks in my brain. you remember like the old school circus, like the trapeze artists, they used to do they fly through the air with the greatest of ease? Your thumb is the trapeze artist attached to the trapezium carpal bone. When we isolate the trapezium and we look at its joint surface for the first metacarpal, we see again that distinctive Pringle shape. Now, just to be clear, Dave is the only one that says Pringle, everyone else says saddle. So I'm just trying to give you a mental image here. But the saddle joint also has a unique array of motion. We can add and abduct, we can flex and extend, well, flex and extend, AB and adduct, we can circumduct a little bit. But the really cool motion that we get out of this joint, that you can only get out of this joint, is a movement called opposition. Now, it's not a movement maybe that you're kind of expecting, but opposition looks like this. Touch the thumb and the pinky, touch the thumb and the ring finger, touch the thumb and the middle finger, touch your thumb and index finger. That right there, that's fancy, y'all. That's fancy. That is a higher order primate characteristic. Dogs can't do this, right? You ever seen a dog try to get a treat off of a high counter? Maybe they can like paw and swipe, but they can't pick up. They can't grasp and manipulate and turn it over in their hands. This is the hallmark of tool use, and this is what sets humans apart. Our closest cousins, the chimpanzees, can do this as well. They also have opposable thumbs. But our next closest cousins, the gorillas do not have opposable thumbs. They have super long fingers and short, tiny, stubby little thumbs. We'll take a quick little side note here. If we look at a gorilla hand, not a costume, thanks. Real, how about that? How about real? Oh, there we go. Nice long fingers, short, stubby little thumb. So that is a hand that is designed for brachiating. That is grabbing the branch and swinging through the trees, right? They've got a gripping hand that they hang from, but that thumb isn't opposable. So they're not really good at picking up and manipulating objects. For example, picking up two stones and striking them together precisely to get a spark or to get a shaved off piece of that broken rock, which they would use to make a blade. So flint knapping. Anyway, my point is opposable thumbs, that's a human thing. That's special to like us and chimps and like bonobos. Anyway, my ultimate point is that the saddle joint is special. It's unique. And you only get two. You get one at the base of each thumb. That's it. Goodbye. You blow that thumb joint out, that's your massage career. So baby your thumbs. I've told you guys over and over, thumbs are for friends and family only, and then only on the high Jewish holidays. You got to spread those things out. Don't overuse your thumbs. Use other tools to apply pressure, like elbows or forearms or braced fingers. Okay. Sites of caution, the median nerve. The median nerve is a little bit accessible right through the carpal tunnel. The main nerve that we will most likely be dealing with is the ulnar nerve. That's the funny bone. You find that one right there in your elbow. The radial and ulnar arteries are running through here, but generally, guys, arteries run deep within the limb. Veins are more superficial. So blood comes in through the core, the central portion of the limb, and then the veins kind of come out and return blood along the more superficial sides. So unless you're just holding and sustaining a lot of pressure right on the forearm, the arteries usually aren't something to really be careful of. But you can take someone's pulse at the radial artery, which crosses the radial artery crosses the distal radius. So that's why we're always aiming right there at the base of the thumb to feel the pulse. So the median nerve that's the carpal tunnel nerve. It's the only nerve that passes here through the carpal tunnel. It's that nice little divot that your finger wants to fit in. You can kind of close your hand over it. Carpal tunnel sits right there. The median nerve innervates this part of the hand only. So if we remember our anatomical position, this is the lateral side. The lateral side, thumb and the first two fingers on the palm side of the hand. The ulnar nerve traveling along the ulna innervates this part of the hand. So when you get carpal tunnel only affects median nerve. You only get symptoms in these three fingers. The radial nerve coming along the radius innervates the entire posterior side of the hand. So radial, ulnar, median nerve. This is the carpal tunnel nerve. There's the little diagram. Where the ulnar nerve passes on the left-hand side, that's up in near the elbow, where it's real superficial. Other interesting structures, we've got the palmar aponeurosis. This is like a fingerless glove of thick fascia on the palm. If you kind of flex the palm, you'll notice how the palm goes into a nice little cupped shape. If you press down very gently, the whole surface of the palm seems to be tensed. That's what you're feeling, that sheet of tendon, that flat aponeurosis. All it takes is a little bit of a flexion, almost like you're holding a very large ball, and you'll feel this broad, smooth, flat firmness arise. If you relax the hand, you'll notice it goes away because there's no longer tension on the aponeurosis. Next, we have the flexor retinacula. A retinaculum, if you think about them like bracelets or anklets, where lots of tendons are all traveling in the same direction, a retinaculum is a strap that just holds all of them down in place. So the flexor retinacula runs from the pisiform and the hamate all the way to the lateral hand where the scaphoid and trapezium go. I will show you guys in the anatomy app. This is going to sit right over the wrist. There is your flexor retinaculum. Crosses right there. Now, this one is called the flexor retinaculum because all the muscles on this side of the forearm, when inserting in various points on the hand and fingers, when these guys contract, they flex. They will create a fist with an F. The extensors on the backside, when these guys contract, they will create extension. So we have flexors on the anterior side, extensors on the posterior side. So all the flexor tendons are held down by the flexor retinaculum. The extensor tendons are held down by an extensor retinaculum, which will be on the posterior side. Oh, and there you can also see the palmar aponeurosis. Good stuff, fun stuff so far? Everybody good? Cool, cool. Ooh, that looks awful. All right, carpal tunnel syndrome. We've talked about carpal tunnel already. Ulnar nerve impingement occurs when the ulnar nerve gets impinged. Symptoms will include numbness, tingling. You guys know when your foot falls asleep, you get that weird like static feeling. It's like pins and needles. The medical term for that is, oh God, the word just fell right. Synesthesia. Synesthesia. So Pain, numbness, tingling, synesthesia, like the pins and needles, kind of static feeling all along the medial side of the hand. Usually it's entrapped at the elbow because that's where the nerve is the most superficial. So I would start working on muscles in the elbow if they're getting ulnar nerve syndromes. So tenosynovitis and tendinitis, these are two distinct conditions and they're often misdiagnosed for each other and they have separate treatments. So I do want to take a moment to talk about the difference between the two. First thing that I want to talk to you about is when we look at a tendon, our app and usually most of our anatomy books just dive straight into the tendon. The tendon is sitting there, the muscle contracts, the tendon is pulled, and the anchoring spot on another bone, that anchoring spot moves. So we create some kind of movement when the muscle contracts. But the tendon isn't just sitting in the tissue naked. It's wrapped in a connective tissue layer called a tendon sheath. So if you think about like a sword sheath, when the old guys in the Middle Ages used to fight with swords, the sword slides into the sheath, but the sheath doesn't really move, right? The sword is what moves. Tendon sheaths operate pretty much the same. It's a tunnel that contains the tendon. Within that tunnel, the tendon is sliding, but the tendon sheath isn't really moving. We have a sliding surface going on inside of here. So back to our point. Tendonitis, the name tendonitis, is an inflammation of the tendon itself. Tenosynovitis is an inflammation of the tendon sheath. Two separate structures afflicted with inflammation. Tenosynovitis is the inflammation of the fluid-filled sheath. The fluid is synovium, same kind of synovial fluid in the joints. It surrounds the tendon and lubricates the tendon so that it doesn't create friction as it slides against its sheath. Symptoms include pain, swelling, and difficulty moving the joint because the tendon is becoming compressed. This can cause a finger to stick in a flexed position. This is called stenosing. So the finger gets stuck in a flexed position. This is also called trigger finger. Happens a lot of times from people that shoot guns a lot. But if it happens in the thumb, and now the thumb is stuck in a flexed position, this is de Quervain's syndrome, named after the guy who first described it, of course. So de Quervain's is the thumb. Otherwise, it's usually called trigger finger. Good stuff, fun stuff. All right, movements of the wrist, beginning and anatomical position. We have flexion, moving the hand up towards the face, and we have extension, so moving the hand towards the back of the body. Abduction, which is also called radial deviation, is deviating the hand towards the radius. You're probably not going to get that much movement. You will probably get more adduction or ulnar deviation, deviating the wrist towards the ulna. So think about your like your parade floats, lady, right? When they're doing the wave, radial deviation, ulnar deviation, whichever side you're coming to, towards the radius, which is on the thumb side because the radius is rad, or ulnar deviation towards the pinky, just like your great auntie Ulna, proper lady. Adduction, abduction. Movements of the thumb, yeah, I talked about this already. Flexion, extension, moving the thumb around, opposition, touching all your fingertips. Thumbs are dope. Fingers flex, fingers extend. You can also abduct or adduct the fingers. All right. There are 5 main flexor muscles of the wrist and fingers. And before we start getting overwhelmed with the names, Words are our tools. They are not our masters. The names of these muscles are trying to tell you something. The name flexor tells me a couple of things. Number one, it tells me what the muscle does. It's flexing. But that also clues me in as to where the muscle is going to sit. Flexor muscles will be on the anterior side, on this side of the forearm. So every muscle with an extensor in its name, those will all be found on the posterior side. Remember, because posterior muscles extend and anterior muscles flex. Cool. The middle name, carpi or digitorum, tells me what structure is being flexed. So if we're flexing the wrist, it looks like this. If we're flexing the digits, it looks like this. Notice the two separate joints that these movements occur. Radialis and ulnaris tells me where, like which side of the wrist the muscle is inserting. So we have a flexor on the radial side and a flexor on the ulnar side. The superficialis is superficial, but it's the one flexing the digits. And last, we have palmaris longus. Palmaris will be found in the palm, and it's a longer muscle, so it's longus. Wherever there's a longus, there's a brevis. So there's a palmaris brevis in here as well. I don't think we're going to cover that particular one, but now flexors all share a common origin. Flexors begin at the medial epicondyle of the humerus. So if you find the very prominent bony bump on the medial side of the elbow, all of your flexor muscles start there and cross the front of the forearm. Likewise, all of the extensors start on the lateral epicondyle and they cross the posterior forearm. They will also likely originate off of the interosseous membrane, which, let's cut all the muscles out. There. It's a strip of dense fascia that runs between the two parallel bones. So when we're talking about origins and insertions, guys, if you just throw interosseous membrane in there, you're likely going to be correct. Notice those distinct holes. Those are there in real life. Those are meant to allow blood and nerve to pass through the membrane, so to get from one side to the other. So forearm muscles, particularly flexors, all originate from the common flexor tendon on the medial epicondyle of the humerus. The first muscle we will examine is flexor carpi radialis. So flexor carpi, it flexes the wrist. Radialis, it's on the radial side, on the thumb side. It's got a common origin with all the other flexors. Common flexor tendon on the medial epicondyle. It inserts at the base of the second and third metacarpals. This is one, so second and third. 1, 2, 3, there. So it will pull the palm of the hand toward the elbow. That creates flexion. This muscle crosses on the radial side. And since it's on the thumb side, it will flex and it will abduct, which is radial deviation. So we can pull the thumb, or the hand rather, down towards the elbow this way or this way. Its close cousin, flexor carpi ulnaris, flexor carpi. It's also a flexor, so it will share the same origin. This guy will insert on the insert on the pisiform. Now we're on the ulnar side. Hook of the hamate, same little spot, and base of the fifth metacarpal. 3 little spots, all right here. So we also get wrist flexion and ulnar deviation. Let's see if I can get these to show up. So here's our first muscle, flexor carpi radialis. We see it, as with all the flexors, share that same origin. This muscle will cross the forearm. They become tendon about halfway down. We tuck under the flexor retinaculum, remember, because that thing holds everything down. So we tuck underneath it. And we insert with this neat little, there, base of the second and third metacarpals. So, wrist abduction or radial deviation. And we get wrist flexion.
Is the flexor carpi radialis the most prominent tendon on the radius side? Like when you, like, can you feel it?
The most prominent tendon usually are the central, the one right in the middle. And just through a trick of evolution, if you flex your wrist, you'll notice I have two side by side.
Yeah.
Or you may have one. So
Okay.
one single tendon, or you may have, where's it at? There we go. Two tendons kind of side by side. Or you might be a genetic freak like me and you get one of each. Those are usually going to be flexor digitorum superficialis. So it flexes the digits.
Oh, okay.
And here on the app, you can see they've got, there on the app, you see that tendon divides in two. So there's actually two side-by-side tendons from the same muscle.
Mm-hmm.
Some people's don't divide that way and they just get the one tendon.
Okay. So you can't really feel.
It's in there, but it's not the most prominent tendon. That was your
Okay.
question. Which one was
Yeah.
the most prominent?
Yeah. Okay.
Yeah. So when you flex your wrist in, you'll see several tendons pop up. Radialis is going to be off here, off to the side, off here, off to the side. But the most prominent will be flexor digitorum superficialis. Oh, we didn't do ulnaris. Sorry. Okay, let me switch through every flipping screen I have. Flexor carpi ulnaris. So same insertion, or sorry, same origin. And this one does start on the olecranon process just a little bit, kind of the proximal 2/3 of the shaft of the ulna. So it does get a little bit more of a broader origin. Crosses the wrist and inserts there on the pisiform. And it doesn't start on the hook of the hamate, but it doesn't illustrate the insertion on the hook of the hamate. All right, yellow tendon is carpi ulnaris. It's inserting onto the pisiform. But what it's not showing you, that little green bony projection right next to it, this one here, that's the hook of the hamate. So this one does actually reach over and insert there as well. But again, every app is just going to show you something a little bit different, but it does insert there. So now we go to its motion. Flexor carpi main action is going to be wrist flexion. And since it's medial, it will also do adduction. Good stuff. Good stuff. Flexor digitorum superficialis. So flexor digitorum is going to flex the digits, flex the fingers, with the exception of the thumb. It doesn't touch the thumb, just the 4 fingers. Origin, common flexor tendon, off the medial condyle, same as the others. We also get a little bit of the coronoid process on the anterior side, and, excuse me, some of the proximal radius. So this one also gets a little bit more of a broad origin. It inserts on the sides of the middle phalanges of digits 2 through 5. Remember, we count 1, 2, 3, 4, 5. So 2 through 5 are these guys. Flexor digitorum flexes the fingers, but since it flexes and it crosses the wrist, remember, if it crosses a wrist, it's got to move that joint. So flexor digitorum will also flex the wrist, crosses both joints.
Dave, isn't it crossing the elbow joint too?
It does not cross the elbow joint.
It does. Oh, it like goes alongside it, like around it?
Alongside. It does not.
Got it. Okay.
But we can see it clearly.
I'm not understanding how that's not considered crossing it. Because
it's not crossing the joint in a position that it can assist with flexion. Because in order for it to assist with flexion, it would have to cross on the anterior side of that joint. It doesn't. It crosses on the lateral side, but a hinge joint can't move laterally.
Oh,
So
right.
There's no way for that muscle to create any movement. So
yeah.
we can debate the, like, how do we define crossing a joint? But what I'm saying, it doesn't cross the joint in a way that allows movement.
I get it now. Yeah. Thank you. That was helpful.
Yeah. No, I want you guys to get it. It's tricky stuff. This gets tricky. We'll zoom in and just take a look at those little insertion points.
It says that we do not need a muscle card for this muscle.
This is a tricky muscle to draw.
Okay. Sounds good.
Because you got to draw the hand bones to get all of those insertion points too. It's I mean, if you're an artist, you could totally go for it. I won't stop you. So since this muscle crosses the wrist, we get both finger flexion and wrist flexion. But remember, its name is flexor digitorum. So its primary action is flexing the digits. Its synergistic action will be flexing the wrist. It's a robin for wrist flexion. The prime movers for wrist flexion will be those whose names tell you flexor carpi. Those guys do the work themselves. Good stuff. All right, next up we have palmaris longus. Palmaris longus, since it also originates off of the flexor tendon, it is also going to flex the wrist. This one is also going to tighten the palmar fascia. So what we were feeling earlier, to feel that palmar aponeurosis just slightly flexing, cupping the palm, that's what palmaris longus does. When you cup the palm of your hand, if you place your fingers over your forearm, you'll feel that muscle right through there. You'll feel it tightening up. You can almost isolate the belly of that muscle. It's right there, right in between my fingers. So its insertion is going to be the flexor retinaculum and the palmar aponeurosis. So when it contracts, it will flex the wrist and tighten the palmar fascia. Come on. There we are, palmaris longus. So you'll feel it more on the ulnar edge, that little belly running on the proximal side of the forearm, closer to the ulna. As you start to cup the palm in, your fingers will find this kind of diagonal, slender belly. And its insertion is not into a bony landmark proper. It's going to insert into the connective tissue. So it's inserting onto that flexor retinaculum as well as onto the palmar aponeurosis. Palmaris longus. All right, folks. Any questions so far? Questions, comments, concerns so far? Cool, cool. All right. So we've covered the wrist. Next, we're going to look specifically at the thumb. So we have thumb flexion, we have thumb extension, AB and adduction of the wrist of the thumb. First, we look at flexor pollicis longus. The medical name for the thumb is the pollex, P-O-L-L-E-X, pollex. So when you see the middle name pollicis, it's related to or of or referring to the pollex. That tells you what the thing is moving. It flexes the thumb, and it's the long muscle that does that. Versus, did we learn the other one? No, there is a flexor pollicis brevis. There is another muscle that flexes the thumb, but it's a shorter muscle. Flexor pollicis longus originates on the anterior medial surface of the radius and the interosseous membrane, right about in here. And it inserts at the base of the distal phalanx of the thumb. So just distal to your thumb wrinkle. It's going to insert right about there, right about there. So from the anterior side to the end of the thumb, when it contracts, it's going to pull the thumb forward in anatomical position, pulling it forward into flexion. Sorry, it's hard to get my hand in anatomical position on my little camera. Hold on. There we go. Flexion, ta-da! And here we have flexor pollicis longus. Starts on the inner side of the radius, crosses the wrist, and it inserts at the base of the proximal phalanx, sorry, distal phalanx of the thumb. And it does thumb flexion. Muscles of the thumb will also allow for opposition. Now, I would just like to take a moment here just to say something. When we talk about opposition movement is a movement of the thumb. It's the ability of the thumb to touch the tips of all the other fingers. So when you look at this action happening, yes, you see the pinky moving. Pinkies do not do opposition. That's a thumb thing and a thumb thing only. Just to clarify, just wanted to clarify that.
So opposition, it's not necessarily the thumb touching any of those fingers, right? It could be the thumb kind of like coming towards them, right? Or is it only when they make contact?
Yeah, the definition of the opposition movement is the thumb touching the tips of the other fingers.
Oh, it is.
That's
Oh, that's weird. Okay.
Then what's the movement called if it goes all the way except the last 28th of an inch but doesn't touch? I think is what Amelia was getting at, if I'm not wrong.
we're saying like it goes all the way, but it doesn't touch.
Yeah, is that what you're asking, Amelia? Like, is opposition only considered when they make contact?
I guess, yeah, I just wanted clarification on that. So yeah, if they go like almost all the way but don't touch, yeah, what is that? Is that let's see, adduction?
I would say opposition is the placement of the thumb in position rather than actually achieving the grasp.
Okay. Right. Okay.
So this is still opposition even though they don't make contact.
Okay.
That is opposition.
Right.
That
Okay.
right there.
Got it. Okay. So it is just that motion.
Just that movement.
Got
Mhm.
it. Okay.
And that's what we mean when they talk about opposable thumbs, is that you can pick up something and turn it over in your hand and like flip it around. And you got to have a thumb to do this. An opposable thumb. You got to have an
I
opposable.
think this opposition thing makes our fine motor skills, right? I mean,
Precisely.
writing and
Precisely. Yeah. Fine motor skills would be things like writing, sewing, typing.
okay.
Mhm. All right. Flexor pollicis longus. Next, we have extensor pollicis longus. So this is the long muscle that extends the thumb. And since it crosses the thumb side, it will also do abduction of the wrist. Extensor pollicis longus. Oh, that's brevis. Where's your longus? There. Extensor pollicis longus. So because this is an extensor, this one is now going to be located on the posterior side. It will start on the posterior surface, about the medial third of the ulna or so, and the interosseous membrane. It will insert on the dorsal aspect of the base of the phalanx of the thumb. So it will insert about there, right about there, above your thumbnail. This muscle does thumb extension. And because it does cross the wrist on the backside, it will assist with wrist extension as well. Extensor pollicis longus. As we've said before, wherever there is a longus, there will be a brevis. This will be a muscle that will be similarly shaped, similarly positioned, but when you cut the muscle out and lay it on a table and stretch it out and put a ruler next to it, this one will be smaller. than the other, shorter than the other. Extensor pollicis brevis also originates on the posterior surface of the radius this time. So not the ulna, but the radius inserts at the same spot, base of the proximal phalanx of the thumb, just above your thumbnail. And just like its brother, it will do thumb extension and abduction of the wrist. So radial deviation. And we can see still highlighted in yellow is the longus, our brevis, should be there. Originating off the radius and the interosseous membrane, inserting, whoops. This one did not insert on the distal phalanx. This one inserted on the proximal phalanx. So there. And it does thumb extension. But we can also see, since it does thumb extension and it crosses the wrist, it will also do radial deviation. So. All right, last one. Abductor pollicis longus. Abductor tells you it will be abducting something. Abduction will look like this. One more time, like this. Origin, posterior radius, posterior ulna, interosseous membrane. Insertion, base of the first metacarpal. That is going to be right there. Right there, just off the wrist. So this muscle will abduct the thumb. It will also extend the thumb, and it will abduct the radiocarpal joint, which again, as we've said, is radial deviation. So looking at the thumb, in our bony format, we see extensor pollicis longus, the long one. Next, extensor pollicis brevis, the short one. And abductor pollicis longus, the one that abducts. It will do thumb extension. And abduction. And there we do have it, folks. So, read up on the trail guide, muscle cards, flexor carpi radialis ulnaris, flexor pollicis longus. We did cover all these. So 7 muscle cards. Olivia, which muscle were you talking about? There wasn't a muscle card due for it. Flexor digitorum. Flexor digitorum superficialis. Yes, that's the one. That's the one that we covered with no muscle card.
And we need muscle cards for all the elbow muscles.
This
Bicep.
week.
Yeah,
Yeah,
biceps, triceps.
those are coming up. Yes, biceps, triceps. brachialis, and coneus. Those guys are due this week. Next week will be flexor carpi, radialis, and ulnaris, flexor pollicis longus, and extensor pollicis longus and brevis. These guys.
Cool.
Yeah, fun stuff. All right. Any questions, comments, concerns? You actually made really good time today. All right. With no more questions, you guys enjoy your afternoon. I will see you all on Thursday.
And I can still do the online option, right?
Yes,
Thank you.
Okay. Thank you.
of course.
Thank you.
Thank
Casey, can you hang out for a sec?
Bye.
Bye.
Later.